Hi, I'm Kevin Watt. I'm going to be conducting a presentation on mountain caribou population growth using the simulation program in Program Mark. Just a little background on my study organism. I'll be looking at the pink mountain caribou herd in northern British Columbia, Canada. They are classified as part of the northern mountain ecotype of caribou. All mountain caribou, as well as boreal caribou, are considered one species, known as woodland caribou, but are divided up into different ecotypes, allowing for different designations. There are 36 identified herds of northern mountain caribou in Canada. Mountain caribou are divided into ecotypes based on their geographic location, behavior, and habitat preference. All northern mountain caribou are listed as a species of special concern under the Canadian Species at Risk Act, also known as SARA. Mountain caribou herds are generally smaller than barren ground caribou herds and do not have as large migrations, but seasonal migrations are characteristic of this type of caribou. Generally, mountain caribou have cow-to-calf ratios of 50 to 75 calves per 100 cows, but usually only 30 to 50% of calves survive to 1 year due to predation, and calf survival to 1 year has been even lower in some areas over the last 10 to 20 years. It is believed that calf survival ratios have been declining due to an increased population of wolves and other predators. It is believed that wolf populations have increased in caribou ranges because there is an increase in moose, elk, and deer populations. It is believed that these ungulate populations have increased due to habitat change, as there has been a fair amount of logging and other anthropogenic disturbances leading to an increase in early cereal stage habitat, which is preferred by moose and deer, while caribou favor intact old-growth forests with sufficient lichen growth. Oil and gas exploration has also occurred in caribou habitat, creating linear disturbances, which allows for wolves to have easier access to caribou within their herd ranges. Caribou are not the wolf's primary prey, but will predate upon them when they are encountered. Historical female survival rates of caribou are between 0.85 and 0.95, but have been much less over the last 20 years in many herds as the populations have declined. In some areas, predator control has taken place in an attempt to recover caribou populations. So just a little introduction on my simulation I did run with Program Mark. As I said before, the pink mountain herd has been declining, and I want to look at what survival rates and recruitment rates would be needed to meet a target population in order to recover the pink mountain herd. So as we have throughout this class, I was going to use Program Mark to run a simulation to determine what recruitment survival rates would be needed to meet the target population. I'm going to use a robust design Pradal recruitment model to run the simulation, and phi is survival in this model, F is recruitment, and P is the probability of detection. So the research question I was looking at is I wanted to determine what recruitment rate is needed to meet a population goal of 850 caribou over 5 years. I want to adjust detection probabilities and survival rates to see how the different parameters affect the ability to meet the population goal of 850. So the key vital rate I want to look at in this simulation was recruitment, but I also want to look at how survival affected population growth as well as recruitment and how these interacted to meet the population target. And I also look to see how detection probabilities affected the confidence intervals for the population goal. For my sampling design, I chose a robust design Pradal recruitment, Huggins likelihood P&C. I ran 100 replications per scenario, and there are 16 scenarios, which I'll get to in a slide or two. I only had one group, which was the pink mountain caribou herd. I didn't need to divide it into any more groups. I had 5 primary occasions, which were the years, and 2 secondary occasions. But I made P and C, the primary and secondary occasions, equal, as generally you only sample these caribou once a year. And I wanted to detect population trends over 5 years. The true model was phi, which is survival, bracket T, time per year, F for recruitment, time. As I said before, the primary and secondary occasions were equal, so P bracket T equals C bracket T. The caribou were captured through aerial net gunning and collared and marked, so they could be resighted during the subsequent primary occasions, which would be 4. The initial release of caribou was figured out using equations based on the Nichols-Ayal study. MT plus I, which is the initial release, equals P probability of detection bracket F, which is recruitment, and bracket T plus 1 initial release again, and phi, which is survival, times M plus T again. And that's how I came to initial release, which is 300. The statistical analysis for this simulation was relatively simple. I wanted to compare estimates of different recruitment, survival rates, and detection probabilities to determine what effect these had on population growth. And I would calculate the confidence intervals for all the different simulations in terms of derived estimates for populations for years 1, 2, 3, 4, and 5, as well as calculate the lambda. For the data type and true model, I'll just go over this quickly as I've gone through most of this. I'll use the robust design, Pradal, recruitment, Huggins, and likelihood PNC model. The true model is phi t, ft, pt equals ct, and be running 16 different scenarios. There is no need for any other model under this simulation, as I'm just monitoring population growth and how different parameters affect the population growth. And to meet the target population of 850, the confidence intervals will have to be above that target population. So the lower estimate cannot be below 850. So these are the 16 different scenarios I ran with different parameter values for recruitment, survival, and probability of detection. The first 4 scenarios had low survival at 0.65 and a low capture probability of 0.7, and recruitment for the 4 different scenarios was 0.2, 0.4, 0.6, and 0.8. The next 4 scenarios had high survival, so it was boosted up to 0.85. The recruitment scenarios were the same, and the probability detections were the same. Next 4 scenarios had a low survival rate, 0.65 again. The probability of detection was raised to 0.9, and the recruitment rates were the same. And the next 4 scenarios had a high survival rate, again, of 0.85, high detection rate of 0.9, and the recruitment rates were the same. And here are my results of the simulations. As you can see, the scenarios in bold are the ones that ended up above the population goal of 850, and a lot of them were well above that. But the remaining 10 scenarios were below it, and all the 6 scenarios that were above the population goal of 850, even their confidence intervals were above that, so they met the population goal. So these were the lambdas for the different scenarios. As you can see, the ones in bold are the scenarios that made the population target, and this just kind of shows that lambda has to be above 1.25, I believe actually 1.3, to meet the population goal. And for these scenarios, the lambda was well above those to meet the population goal. So just to take a little bit closer look at the results here, the results from scenarios 1 to 4, they had low survival, low detection, and the first 3 scenarios were below the target population goal, but recruitment was boosted up to 0.8. As you can see on the graph, it is above the target population goal, which is shown on the green line on the graph. So on the second groups of scenarios 5 to 8, when survival was boosted up to 0.85 and detection probability was 0.7, Two of the scenarios with recruitment 0.2 and 0.4 were below the population goal, while recruitment was boosted up to 0.6 and 0.8, it was above the population goal. And even with confidence intervals, both of those are well above the population goal. And for scenario 8, even in year 4, the population had already gone above the population goal. So for scenarios 9 to 12, these were very similar to scenarios 1 to 4. The only difference was they had a high detection rate. So the estimates were fairly similar. The only difference was there were lower confidence intervals. So the confidence intervals were smaller, which mean more accurate estimates. But again, only one scenario, scenario 12, met the population goal for this group of estimates. So again, these scenarios of high survival rate, high detection had very similar results to scenarios 5 to 8, again with just slightly lower confidence, tighter confidence intervals due to higher detection probabilities. So all the scenarios that met or exceeded the population target of 850 had at least a recruitment rate of 0.6. And all recruitment rates that were 0.8 met or exceeded the target populations. When survival was high at 0.8 and recruitment was 0.6, all of these scenarios also met the population goal. And the probability detections did not have much of an effect on the estimates. Again, they just had tighter confidence intervals compared to the scenarios with lower confidence intervals. But this just shows that if a recruitment rate of 0.8, which is extremely high for caribou in the wild, can be met, then this population target of 850 would be met. And if survival is 0.85, then the recruitment rate would likely only have to be 0.6 to meet the population target. In conclusion, this simulation shows that to meet the target population of 850, a high recruitment rate of 0.8 is needed to meet or exceed the population goal of 850, especially if the survival rate is 0.65 or lower, which is characteristic of a lot of caribou herds in the northern mountain ecotype during the present time. But if the survival rate is increased to 0.85, then a recruitment rate of 0.6 is sufficient to grow and meet the population goal of 850. Both of these recruitment rates are generally much higher than what is seen in present-day caribou herds in northern BC. It has been shown that these recruitment rates can be met through human intervention. Both predator control and maternity pens, which exclude predators, can increase recruitment rates of mountain caribou. And these interventions have taken place in some caribou herds in BC and have proven to grow population numbers. But these mitigation methods are a short-term solution, and in order to maintain caribou populations in northern BC, longer-term solutions have to be explored, which include habitat protection and restoration. But restoring caribou habitat takes a long time. Therefore, short-term solutions may have to be implemented to achieve the target survival and recruitment rates that are needed to grow population and avoid extirpation. Thanks for taking the time to listen to my presentation, and hopefully you enjoyed it.